Welcome all. Now I am going to discuss question number 47 from the GATE 2019 paper Electrical Engineering. The question is a delta connected 3.7 kilowatts 400 voltage line 3-phase 4-pole 50 Hz squirrel cage induction motor has the following equivalent circuit parameters per phase referred to the stator. R1 is equal to 5.391 ohms, R2 is equal to 5.722 ohms, X1 equal to X2 equal to 8.2212 ohms. Neglect shunt branch in the equivalent circuit. The starting line current in amperes. You can round up to 2 decimal places. When it is connected to a 100 volts line, 10 Hz 3-phase AC source is. To know the detailed modeling of equivalent circuit of an induction motor, audience can go through the given NPTEL video link. Let us discuss the equivalent circuit representation of the induction motor. Induction motor usually takes supply from the grid. Here R1 is the stator resistance, R2 is the rotor resistance, X1 is the stator reactance, X2 is the rotor reactance. By using this information, let us solve the problem. So, given data, given what it is, 3-phase, 4-pole, 50 Hz, squirrel cage induction motor. And the rating of the motor P is equal to 3.7 kilowatts. The voltage is line to ground, so 400 volts means this is per phase voltage, 400 volts. And the induction motor parameters, it is given as R1 is equal to 5.391 ohm, R2 is equal to 5.722 ohm, X1 is equal to X2 is equal to 8.2212 ohm. So what we need to find out is, now again the induction motor is connected to a 100 volts 10 Hz source. 100 volts 10 Hz source. We need to find out the starting line current drawn by the induction motor from the AC source. So, let us solve the problem. Thing is that starting line current we need to find out. Here, induction motor parameters R and X values are given. R is independent of frequency. R is independent of frequency. But X is dependent of frequency, right? Because since X is equal to omega L, means 2 pi f L. So, reactance of the induction motor is directly proportional to the frequency of the supply. So, in the question given initially F1 as 50 Hz. But starting line current we need to find out for the frequency of 10 Hz. So, new values of X1, X2 we need to find out. X1 new, that is 50 Hz. X1 old is equal to F1 new divided by F1 old. So, X1 new we need to find out divided by X1 old. X1 old, X1 new we need to find out divided by X old is 8.2212 ohms is equal to F new is 10 divided by 50, which implies X1 new is equal to 1.664 ohms. So, if X1 new is equal to 1.644 means X2 new is also equal to 1.644 ohms, since the stator reactance and rotor reactances are equal. So first we will find out the phase current, that is phase voltage given by Z. Voltage is how much? 100 volts divided by Z. Z, right? We need to find out. R1 is how much, guys? 5.39 plus R2 is 5.72 plus J into X1 new is 1.644 plus X2 new is 1.644, which is equal to 8.63 amps. This is only the magnitude. So this is phase current, but we need to find out the line current, right? So I line starting only this one. I line start is equal to √3 into I phase start. I phase start. So √3 means 1.732 into I phase is 8.63, which is equal to 14.95 amps. So if the induction motor is connected to the 100 volt supply and 50 Hz frequency, the starting line current drawn by the induction motor is 14.95 amperes. So the starting line current drawn by the induction motor when connected to a 100 volts 10 Hz 3-phase AC source is 14.95 amperes. Thank you.